right, everybody, here we go. It's go time. If you're a little intimidated, I don't blame you. This is tricky stuff, but stick with it and you can figure it out. My goal here, I'm going to help you out with San Jose, and I'm debating on what I'm going to do. Maybe I'll pause it and have you try to figure it out and then do some of them. I suppose that's what I'll do. So I'm going to help you through the first one, but I really recommend that you try it when I say pause. You can go ahead and just go right to the end of this YouTube video, see all the numbers are out in there, copy them into your sheets. But then when I say go, do New York and San Francisco, and they're worth points, you're going to be, you're not going to know what's going on. So again, I'm on your side. I'm trying to find the easiest way through this very difficult thing. So try to roll with me, my friends. All right. First things first, San Jose. Here's what one of these things is going to look like. Both, you're going to do New York and San Francisco on your own with no video help. And then when you do the lab, it's going to look just like this. So what we got to do is figure out, when did the P wave get here? When did the S wave get here? I think it's easiest and helpful to draw a line. So that will go like right there. And it's just going to give us a little bit better view, I think, of what exactly time the P and the S get there, according to this thing. Okay. I also think it's probably in our best interest to go to the nearest 20 seconds. If you try to get like ultra specific here, you might end up just complicating your life, especially with the arithmetic and time. That really tangles people up. I mentioned in the last video that there are time calculators out there on the internet. Since this is a COVID year, you're probably at home or you're doing this on your own either way. Use it. If not, we're also going to talk about how you might be able to figure it out manually. Okay, so what time did the P wave get here? This is 13:15. If you don't know military time, what they do at 12 noon is just keep on going. So 13:15 would kind of be like 1:15 in the afternoon. So 13:15, 13:16, 13:17, 13:18, 13:19, I'd say is right there, right? And then about how many seconds are you going to say that is? And again, if we're going to the nearest 20, I think it's pretty obvious, right? Like halfway would be 30 seconds. So I'd say that's about 20 seconds. So we're at 13. Remember, this is 19. 13, 19, and 20 seconds. So that's what time our P wave arrived at. 13 hours, 19 minutes, and 20 seconds. Great. Let's do the same thing for the S wave. S wave right about here. I'm going to say that looks like about 40 seconds. So we're at 13, 20, 21. This would make that 22. So about 13, 22, and about 40 seconds. Should probably do this with a text tool, but what the heck, we're already there. All right. Now, how much time passes between those two? Unfortunately, you can't grab a calculator and type it in, because if you're trying to subtract minutes, your calculator doesn't know that you're dealing with time. And time, like every 60 seconds repeats. If we had 100 seconds in a minute and 100 minutes in an hour, a calculator might be more useful for us. But if you're subtracting 40 and 20 here, your calculator is not going to know that this resets at 60 because they're seconds. So unfortunately, a good old-fashioned calculator is kind of useless. So your options are to go type into Google time calculator, which I have never said to a student before. But since we're in a COVID year, what the heck, give it a go. Or if you want to do it manually, some people can just count. And I mentioned the other one too. When you get an hourly job, you get really good at counting time because you want to know how much you're getting paid. Like if I punch in here and I punch out there, how much did I actually work? What I think is the easiest method of all of them, and again, some people might be able to just run that in their head and do it. If you can, then awesome. Just move on. You got it. What I think the easiest method is, I'm going to just erase some of my chicken scratch here, is to cheat using the timeline. So if this was 20 seconds, then we know we got 40 right here. 40 seconds, dot. That covers like that much time. And then we got a full minute and a full minute. So that's another 2 minutes right there. And then I said that this was 40. So we got 40 seconds. So let's try to figure out what we got here. According to this, I've got 2 minutes and 80 seconds. And maybe that shows you why using a calculator here doesn't really work, because 2 minutes and 80 seconds isn't really a thing. but it is that much time. So what do we do? I'm silent on purpose. Are you thinking about it? Are you figuring it out? What would 2 minutes plus another 80 seconds really be? Well, I think it's if we say that this is really 3 minutes and that 60 of those seconds went into that minute, that leaves us with an extra 20 seconds. So our grand total there for that much time that passed from P to S is 3 minutes and 20 seconds. You could have done that manually. You could have done that with a time calculator on the internet. This year, whatever works for you, whatever gets us there, works for me. I think it's a good practice to write out your times in the same format every time. Yeah. Okay. So now we got it. 3 minutes and 20 seconds separation in between those two. This is where you're going to have to go and figure out how to do that on the reference table that I've sent home. And this is where if you haven't watched those videos, you're dead meat. It's not going to work at all. Okay. So, and it might require like, hey, okay, Mr. F, I watched these. A lot of people have told me that this year. Yeah, I watched it. This is like a little bit more participatory. You got to really figure out how to do these. That's why I put this big gaudy yellow and pink box around this. You might have to watch these a couple times to figure this out. So if you're stuck on the next step, how to calculate epicenter distance, please go back to the survival guide and check that first video in the box. And it's going to take you through it. I think that's better than me trying to just do it all over again. All right. That's going to give you your distance. All right. I think I will figure them out too, just so that we know what's going on. So press pause. I'm going to do the same thing. And we'll figure this out in a second. All right. Pause now. Okay. I'm going to do an answer, but you should have paused and tried to figure it out. Again, you're going to be on your own immediately, so you got to be able to figure these things out. It's coming at you fast. I got 2,100 kilometers. If you said 2.1, all you did was you forgot to just note that those are in thousands on the x-axis on that graph. If you got 2,000 to 2,200, I'm usually like 150-ish. Plus or minus is like an allowable amount of wiggle room. If you're way off that, something didn't go right. Or maybe for me, but I think I got it down. That should be right somewhere in that neighborhood. Okay. So the next question is really the origin time. We want to know, what time did this earthquake actually take place? It arrived, and you can do this with the P wave or the S wave. In the video, I only showed how to do it with the P wave. It's the same exact method with the S wave. You just use the S curve instead of the P curve. But this is the classic question, and this is, again, people get very stumped on this. What time did the earthquake take place? And it's that classic question that I mentioned when I did the video over there. If my commute here is 45 minutes and I arrive at 7 o'clock, what time did I leave? Those are the things you need to know. And you can figure out. You can figure out that I left at 6:15. If this earthquake wave traveled 2,100 kilometers and it arrived at 13:19:20, when did it leave? When did the earthquake actually take place? It didn't actually take place there. It arrived here after traveling for 2,100 kilometers. Now, again, Mr. F, I'm stumped. I got no idea. Then you really got to go to the second video here and watch it again. And I'll repeat the same warning. You got to watch these things a couple of times to get this down. This is tough stuff. Okay. So, yeah. Why don't I do the same thing? I'll pause. I'll go do it over there and come back and we'll get our answers in there. So I recommend you pause and give it a try. In 3, 2, 1, pause. All right, we're back. So I'm going to say that on mine, and again, there's a little wiggle room here. There's a little more wiggle room here. These errors might compound a little bit, but I'm going to say on mine that it was about 4 minutes and 10 seconds. 0 hours, 4 minutes, 10 seconds. And if your number was here was a little bit different, then this number here will be a little bit different. But we're going to allow for a little bit of error. If they're way off, something's wrong. So that earthquake had a commute to this place, to San Jose, of 4 minutes and 10 seconds, arriving at 3:19:20, which means if I've got to subtract those two, and again, this is going to be like not easy to do classically so far in my earth science teaching experience. people struggle with arithmetic time arithmetic, just like I struggle with the English language. So 13, 19, 20. If I subtract 20 seconds minus those 10 seconds, that leaves me with 10 seconds. If I subtract 4 minutes off that 19, that's going to leave me at 15. And no hours, so it's 13. So if our math makes sense, if we say that this earthquake occurred at 13, 15, 10, traveled for 4 minutes and 10 seconds, which would make it 1920. Yep, that makes sense. That works. Okay. So it's your job to do the rest of these. Depending on the situation, on what day you're doing it, it's a really good idea that before you jump into the lab, you see if this is right. Now, if it's like a time where I'm not, you're not actually in class, you can email me. And I check it as regularly as I can. Maybe I'm not at home right at that instant, but if so, I really recommend doing this, saying, hey, Mr. F, I did that. Can you check it out? I'll grade it quick. And if it looks close enough, then we'll go ahead with the lab. I think that'd be the best way. All right. I'll do another quick intro video for the lab. Good luck on New York and San Francisco. You guys can do this. Excellent work. We'll catch you soon.